Well, hi everyone. I have a video on just kind of the solutions on this practice test. And first one is limit as x approaches -4 of 3 over x plus 4. I'm going to graph that one. We'll do 3 over, if it doesn't make that fraction for you, you're going to have to 4. We'll take a look at that graph. Okay. Limit as x approaches -4. So here's -1, -2, -3, -4. It goes way up from the right, it goes way down from the left at -4, which is actually a horizontal asymptote. So that limit does not exist. Okay, let's take a look at the second limit we have here. 4 minus x squared over x minus 2. Limit as x approaches 2. I'm going to write 4 minus x squared as 2 minus x times 2 plus x, difference of squares, over x minus 2. And then these are not going to cancel unless I kind of rewrite this. Limit as x approaches 2. First of all, direct substitution won't work because that makes that denominator 0. So I'm going to go negative out here and make it x plus 2. Now, I haven't changed anything. That's, the x is negative and the 2 is... Okay. I have changed something, but let's get it corrected here. Okay, negative x, right? And negative 2 is positive 2. So this and this are the same thing. I'm not changing anything. I'm just rewriting just to fit our problem here a little better. 2 plus x over x minus 2, because now that'll let me cancel that out. So that's the limit as x approaches 2 of the opposite of 2 plus x. Now, I'm not going to make a denominator 0 now with that simplifying, so I'm going to do direct substitution and put the 2 in for x, and then we're looking at -4. So okay, this answer is -4. Okay, now number 3. The limit as x approaches -3. All right, direct substitution is going to work on this one, so that's what I'm going to do. I'm going to go 2 times -3 minus 1 over -3 plus 1. That's -6 minus 1 is -7 over -2, which is positive 3 1/2. Now number 4. The limit of the cotangent of x as x approaches pi. I don't know whether we should use the graphing calculator or remember what we had with, let's try this. Okay, cotangent. And if you remember, for pi, or I'm sorry, for tangent, it went from -pi over 2 to positive pi over 2. But cotangent actually starts up here and a period is pi units. Here's 0. And if you'll look, as we approach pi, we go down to negative infinity from the left. As we come from the right, we go positive infinity. So this is another one where the limit does not exist. Not at pi. Okay. Number 5, the limit of the square root of x plus 5 minus radical 5 over x, direct substitution won't work. So what I'm going to do is a strategy that we've learned of rationalizing the numerator. So the conjugate of the numerator, multiply top and bottom by that. Okay, so square root of x plus 5 times square root of x plus 5 is x plus 5, and then this would be square root of 5 times square root of x plus 5. This would be negative square root of 5 times x. Those two are going to cancel out. Plus, or not plus, minus square root of 5 times square root of 5, which is 5. Over, and this is, don't forget those limits, x times the square root of x plus 5 plus the square root of 5. Okay, those cancel. So that's x over x times, limit as x approaches 0. The square root of x plus 5 plus the square root of 5. Those x's now cancel out. Now we have a chance, and that's 1. I'm going to write that down. The limit as x approaches 0 of 1 over the square root of x plus 5 plus the square root of 5, 0. So that's 1 over 0 plus square root of 5 plus the square root of 5. That's the exact answer is 1 over 2 radical 5. If I multiply by the square root of 5 times square root of 5, so that I rationalize the denominator now, I got the square root of 5 over 2 times 5, which is 10. And if the instructions say give it as a decimal to 3 decimal places, we can do that as well. And what would we have here? Let's quit out of this and pick the square root of 5 divided by 10. Approximately 0.224. Okay. Now number 6. Let's see, can I put that directly in? That's negative 2 squared is 4. Negative 2 times 5, that's negative 10. Positive 6. Okay, that makes it 0. So I am going, the limit as x approaches negative 2, x plus 2 over, I'm going to factor this, x plus 2 times x plus 3. Multiplies to 6, adds to 5. That's what we need. The x plus 2's cancel. So now we got the limit as x approaches negative 2 of 1 over x plus 3. With direct substitution, that's 1 over negative 2 plus 3, which is 1 over 1, which is 1. And there's number 6 done. Number 7. Okay, the limit as x approaches 16 from the right, and 16 minus 16 is 0, so we're going to have to do something with this. Of 4 minus radical x over x minus 16. Okay. I'm going to Let's try rationalizing the numerator again. Let's see what that does for us. Okay, 4 times 4 is 16. 4 times radical x is 4 radical x. Negative radical x times 4 is negative 4 radical x. Those are going to cancel out. So minus square root of x times square root of x, which is x. So that's the limit as x approaches 16 from the positive side of x minus 16 times 4 plus radical x. Looks like we got some canceling that can happen. But before I do that, let me get this in the right order. And when you have like this subtraction in the wrong order, if I put a negative out in front, then I can go x minus 16. I can change that order, and because that's still negative x, and negative negative, that's positive 16. So I've changed that order, but I didn't really change the expression. I didn't change the expression at all. Whoops. That's x minus 16 times 4 plus square root of x. And those cancel. So I'm looking at negative 1 over, limit as x approaches 16 from the right of 4 plus square root of x. Now I'm going to substitute. I don't have to write the limit, and I do the substituting. 4 plus the square root of 16, which is negative 1 over 4 plus 4, which is negative 1/8. Okay. Number 8. The limit as x approaches 6 of the absolute value of x plus 6 over 6. Okay, I think I'm going to, sometimes we can choose to look at the graph, and this might be one I choose to look at the graph on. Y equals, let me clear this one out, absolute value, that's in math, num, ABS, absolute value, and then x plus 6. In case you wondered what I did there, I hit math, then I went over to num, and then hit 1 for the absolute value. Mine came up with the absolute value bars. Yours may not do that, but still ABS in parentheses is the same thing. Quit out of that. Oh, okay, wait. Okay, there we go. All right, and I'm going to divide that by, I got to use parentheses, x minus 6. X minus 6. I'm going to graph that. Okay. Looks like once again as we approach 6, 1, 2, 3, 4, 5, 6, right there is a vertical asymptote. Negative infinity on this side, from the right it's positive infinity. So that limit does not exist. Okay. If I substitute 5 in, 5 squared is 25 minus 25 is 0. I'd be dividing by 0. So direct substitution is not ready yet. So let's write the limit as x approaches 5 of x minus 5. I'm going to factor x squared minus 25 to be x minus 5 and x plus 5. Those cancel. So the limit as x approaches 5, 1 over x plus 5. All right, we're good to put a 5 in now. That's 1 over 5 in place of the x plus 5, 1 over 10. So that limit is equal to 1/10. Now number 10, for the function f of x equals x squared plus 8, find the slope of the tangent line at 2, 2. So the slope of the secant line is, we've been doing this a lot, f of x plus h minus f of x over h. And so we have okay, so I'm going to put the x value is 2, so I'm going to take f of 2 plus h minus f of 2 and put that over h. Okay, and 2 plus h, that's 2 plus h squared plus 8 minus 2 squared plus 8, down in parentheses, f of 2 plus h, f of 2 over h. 2 plus h squared, that's 2 squared, which is 4, plus 2 times h, which is 4h, plus h squared. 2 squared is 4. 4 plus 8 is 12, so minus 12 over h. All right, forgot that plus 8. This is 12 here. I forgot to write the plus 8. I did square that here. I have this plus 8, and then I have this minus 12. So 4 plus 8 is 12. 12 minus 12 is 0. So this all cancels out, leaving me with 4h plus h squared over h. Which is h times 4 plus h over h, which equals 4 plus h. All right. Now, probably should have just gone, I did this, but, and I will do that on the next one. I'm not going to do this in separate parts, but to find the limit, so we're making that h smaller and smaller to get that tangent line. We're going to take the limit as h approaches 0 of 4 plus h, which is 4, which is the slope of the tangent line of this function at 2, 2. All right. And I'm going to do it on, I'm going to do the same thing at negative 3, 1. So this time, rather than wait for the limit at the end, I'm going to do it at the beginning. Limit as h approaches 0 of f of x plus h (1 over x plus 4 plus h). That's backwards. You put x plus h first. So x plus h plus 4 minus 1 over x plus 4 over h. So direct substitution won't work right now. Let's put the negative 3 in for the x. So that's the limit as h approaches 0, 1 over negative 3 plus h plus 4 minus 1 over negative 3 plus 4 over h. And then that's one limit as h approaches 0, 1 over h plus 1 minus 1 over 1, negative 3 plus 4, over h. I'm going to write 1 over 1 as h plus 1 over h plus 1. So the limit as h approaches 0, 1 over h plus 1 minus h plus 1 over h plus 1, just so we have that common denominator, and that's over h. So it's 1 minus this. 1 1 minus h minus 1. That 1 and minus 1 will cancel out. So I'm looking at negative h over h plus 1 over h. Limit as h approaches 0. Let's take this, negative h over h plus 1, and multiply it by 1 over h. Instead of dividing by h, let's multiply it by 1 over h and cancel that. We got the limit as h approaches 0 of negative 1 over h plus 1. H is 0. Time for direct substitution. That's negative 1 over 1, which is negative 1. That's what the slope of the tangent line at negative 3, 1 is for this function. All right. Find the derivative of g of x equals 7. Derivative g prime of x is g of x plus h minus g of x over h. Oops. It's the limit as h approaches 0. All right, well, g of x plus h. G of x is 7. I put an h in for the x. There's no x there, so I'm going to just make 7 minus g of x, which is 7. This is the limit as h approaches 0 of h. This is the limit as h approaches 0 of 0 over h, which is the limit as h approaches 0 of 0. There's no h anymore, so the answer is 0. That is the derivative of g of x equals 7. Okay. It's the slope of the tangent line of a horizontal line. And no matter what point you're on, the slope at that point is 0. All right, let's find the derivative of f of x equals negative 3x plus 4. So f prime of x is the limit as x approaches 0 of, I'm going to just write this out for the first time, f of x plus h minus f of x over h, which is negative 3 times x plus h plus 4 minus negative 3x plus 4 over h. Boy, I'm forgetting that a lot. Limit as, not x approaches 0, limit as h approaches 0. All right, this is equal to the limit as h approaches 0 of negative 3x minus 3h plus 4 plus 3x minus 4 over h. Which is limit as h approaches 0 of negative 3h over h. That cancels out. The limit as h approaches 0 of 3. That is plain old 3. The derivative of this function is negative 3. Negative 3. All right. Find the derivative of g of x equals x cubed g prime of x is x plus h cubed minus 2 times x plus h. Limit as h approaches 0 times x plus h minus x cubed minus 2x over h. This equals the limit as h approaches 0 of x cubed plus. We've done this a bunch of times. Remember, Pascal's triangle will help us with this. If you don't remember this and you have to do this, then you'll have to take x plus h times x plus h and get your result, and then multiply that result by x plus h, and then you'll have your third power. Okay, but I'm going to use Pascal's triangle because I remember it. And then negative 2x, negative 2h, negative x cubed, positive 2x over h. Cancels. Negative 2x, positive 2x cancels. So that's the limit as h approaches 0 of 3x squared h plus 3xh squared plus h cubed minus 2h. It's over h. Limit as h approaches 0 of h times 3x squared. I'm factoring out the h from the top, plus 3xh plus h squared minus 2. That's over h. The h's cancel. Direct substitution. I'm going to take 3x squared plus 3x times 0 plus 0 squared minus 2. That's 0, and I'm left with 3x squared minus 2. And that is the derivative of x cubed minus 2x. All right, guys, take care.